Trig, sum differences to product. So type 1, we're going to look at using product and changing it to either a sum or a difference using our formula on page 15. So all of these formula on page 15 we only have to be able to use, we would never be asked to derive them. So in the first question here, I'm using question 8 in your books, page 257. So I'm doing part 1 and I'm doing part 9. So we're going to write the following as a sum or a difference. So if we take part 1 there, how do we use these formula? Well, like our compound angles, the first thing you're going to do is write angle A and angle B over the two different angles. And then we go dot, 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 dot. And we read it as 2 sine A cos B. And that allows us to identify which formula we need to use. So if we go to the top of page 15 here, we can see 2 sine A cos B is the second one. And that's basically going to be equal to sine of A plus B plus sine of A minus B. In other words, it's the sum of our two compound angles there. So if we sub in our values, 2 sine 6 theta cos 2 theta can be written as sine A plus B, so 6 theta plus 2 theta, plus sine A minus B, 6 theta minus 2 theta. So therefore, as a sum, 2 sine 6 theta cos 2 theta is basically the same as saying sine 8 theta plus sine 4 theta. And that's your answer. Cannot add those two together. They have nothing in common. It is just sine of one angle plus sine of a completely different angle. So the second one then we want to do is cos x sine 5x. So again, if I write A and B over my angles, well, I have cos A sine B. Now if we go to the top of our maths tables, page 15, we can see that we have a cos A sine B, but we don't have, we have a 2 cos A sine B, but we don't have a cos A sine B. So I know that 2 cos A sine B is equal to sine of A plus B minus sine of A minus B. So therefore, if I divide across by 2, well, I can get cos of A sine B. So in other words, it's just a half of all of that. And now all I have to do is put in my values. So I have a half times sine of A plus B. Well, A is x and B is 5x minus sine of A minus B. And therefore that's a half sine 6x minus a half sine minus 4x. Now we might remember our negative angles from page 13, where I have sine of a negative angle is minus sine of that angle. So therefore I would have to tidy that up by going half sine 6x, and then sine of a negative angle is minus sine of that angle. So therefore that's minus a half times minus sine 4x. In other words, that's a half sine 6x plus a half sine 4x. Okay. Now there's another way of getting around that. You could actually rewrite that as sine 5x cos x, because obviously a product 2 times 3 is the same as 3 times 2, so that's 6. So cos x times sine 5x is equal to sine 5x times cos x. And what that does is it allows you to use, if we go to the top of the page, sine A cos B, this one. But when you go to subtract the angles, you'd have 5x minus x, which is plus 4x this time. So you end up with no negative angles. But I wanted to show you what you would do if you ended up with a negative angle in this example. The type 2 is where we're going the reverse, where we're given a sum or a difference and we're asked to write it as a product. So what you'll see here on page 15 is sums and difference to product. So we're using the bottom half of the page this time. So if we look at the first one, we have sine 4x plus sine 2x. So what we do is we write a and b again over our angles. So again, O is the easiest way to identify the correct formula. And therefore, we are looking for sine of A plus sine of B. Not to be confused with, by the way, sine A plus B. So completely different, okay? Not the same. So the formula then we can see is going to be 2 sine, and we tend to say it as half the sum cos half the difference. So that means that sine 4x plus sine 2x can be written as 2 sine half the sum cos half the difference. In other words, we can simplify that too. Sine, well, 4x plus 2x is 6x, and 6x divided by 2 is 3x. Cos 4x minus 2x is 2x, divided by 2 is just x. So now we have a product, sine times cos. If we look at the second one then, we have cos x minus cos 5x. So again, we write a and b over our angles. And therefore, to identify the correct formula, we're looking for cos A minus cos B. And again, if I go to my tables, page 15, cos A minus cos B is equal to minus, so be careful there, that's a minus, 2 sine, half the sum, sine half the difference. And again, cos A minus cos B is not the same as cos A minus B. So cos A minus cos B, sine A plus sine B, what you're doing is you're adding two ratios. Whereas in your compound angles, you're adding or subtracting the angle and then getting the ratio. So subbing in, minus 2 sine, half the sum, sine half the difference. So again, a bit like the last type, I purposely chose this as an example because it ends up with a negative angle. So 6x divided by 2 is 3x. And then we have sine minus 4x divided by 2 is minus 2x. So I'm going to put brackets around this. I can't switch around the cos x minus the 5x because I still end up with a minus sign there, right? So we always will end up with a negative in this case. But again, if I go back to my previous page there, we saw that sine of a negative angle is equal to minus sine of that angle. And therefore that can be written as minus sine 2 sine 3x times minus sine 2x. So multiply my brackets there. So it's minus 2 sine 3x times minus sine 2x is plus 2 sine 3x sine 2x. And again, I cannot simplify that any further. So type 3 here, we're asked to find the exact values. So when we're asked to find the exact value, it means we can't sub into our calculator and get an answer. We must use our formulas. So again, if we just make a note here, we say note without the use of calculator. In other words, we're going to end up with our special angles again. If you can't end up with special angles, then you would have to use your calculator. So here we have cos 75 degrees, cos 15 degrees. So we're going to write A and B over our angles. So it's going to be cos A, cos B. So again, we have a cos A, cos B in the first one. But of course, it's 2 cos A, cos B, which is cos of A plus B plus cos of A minus B. So if we want cos A, cos B, I must divide both sides across by a half. To get what I'm looking for. So cos 75, cos 15 is going to be written as a half times cos of a plus b, so 75 plus 15, plus cos a minus b, so 75 minus 15. So that's a half times cos, well, we have 75 plus 15 gives us 90, plus a half cos 75 minus 15 gives us 60. So again, we go to our tables and we see cos 90. So we have cos 90 is 0 and cos 60 is a half. So that's a half times 0 plus a half times a half. And therefore the answer is just a quarter. So we haven't even gone to our calculators, but if you were to go to your calculator and get cos 75 multiplied by cos 15, you would end up with a quarter. So the second one then is sine 75 minus sine 15. So again, we put a and b, and we go sine a minus sine b. So if I look at my tables, sine a minus sine b, at the bottom of page 15 there, is equal to 2 cos half the sum sine half the difference. So subbing in my values then, that gives me 2 cos half the sum sine half the difference. And therefore that gives us 2 cos. So 75 plus 15 is 90 divided by 2 is 45. And then times sine 75 minus 15 is 60 divided by 2 is 30. And again, if we look at our tables there, on page 13, we can see cos 45 is 1 over root 2, and sine 30 is a half. So that's 2 times 1 over root 2 multiplied by sine 30, which is a half, and that gives us 1 over root 2. And again, you can check that on your calculator and you should get the same answer. Okay, so what you're going to do for me is, again, on the second sheet, labelled sum difference to product, you're going to do the following questions. So 1, 2, 4, 5, 9, 10, 11, 13, 14, 18, 20, 21, 23, and 24.